So here is our Kakuro grid. Hello and welcome to this new Kakuro solving video in which we're going to look at a handy technique that you can use to help you make progress when solving Kakuro. We get quite a few inquiries with regard to how to solve Kakuro. People can find them quite intimidating at first, and here's a handy tip that many people don't think of that you can use to help you place some given digits right at the start of many Kakuro grids. So the trick is to look at squares that are shared between both across and down runs. So if we look at this across, and this across, and then this down, and this down, we can see that all the squares are shared apart from this one. So I'm just going to highlight those now. So we can see that all these squares apart from the blue one are shared between the across and the down ones. And since we know the totals of each of these, 6 plus 19 plus 16, 20 plus 19 plus 6, then we can say straight away the value to be placed in the blue square is the sum of these downs minus the sums of these crosses. So we have 39 plus 6, that's 45. And then we have 41 there. So 45 minus 41 is 4. So we can place a 4 there to get us started in the puzzle. And now it's just a case of looking for other instances of this. In some grids there are lots of instances and others aren't so many. But we can see over here we have the same thing where we have shared squares in the in-cross and the down direction apart from this square. So we can sum 7 plus 30 plus 35 plus 4. So that's 65, 69, 78, 77. And take away the downs, that's 59. So that's going to give us 9 here by doing the subtraction. So again, just to mark up the shared squares here. Then you can see that all the blue squares are shared between the across and down ones here, apart from this square here. So we've already placed 2 squares. We can do the same thing over in this corner. So let's use green over, no, green might be confusing. Let's use grey over here. So we can see that these squares are all shared apart from the one that's been marked purple here. So we can sum these up and take away the difference. So 17 plus 18 plus 15 plus 16 minus 23 minus 12 minus 9, which is going to give us 2. Oops, one square. Going to give us 2 over here. And sometimes you can't do it with a single square, but you can do it with sets of squares. So if we look over in this corner here, let's use orange. And this time we can see that it's these 3 squares that aren't shared. So this, and this minus this. 15, 4, 16, sorry, 13 and 6, 6, 11 and 12. So if you take that away, you get 9. We've already got the 2 here. So these 2 squares must sum to 9. A 15 sum must be 1, 2, 3, 4, 5. That's the 2. So these options are only 3 and 4. Okay, so that's what this really handy little technique you can use is. Look for single or small groups of squares that are shared between rows and columns of runs in the Kakuro grid. So now let's just take off all the highlighting. so using that rule on this puzzle, we've got ourselves 3 given digits, and we've got a pair here, a 3-4 pair. So now we can just solve the rest of the puzzle as normal. So we know that 15 must be 1, 2, 3, 4, 5. So we have 1, 5, and 1, 5 over here. 17 must be 9 and 8. Well, this can't be a 9, because then this could never total 9. So therefore that must be the 9. And this is the 8, which gives us a 1 here. 19, we need 3 to complete this 12 sum. So that must be 2 and 1. We have the 1 there. Now we have 14 here. So that's 9 and 5, or 6 and 8. Okay, so 23, that's 6, 8, 9. A lot of solving Kakuro just really comes down to learning what the combinations are for the big and small totals. So this can't be a 6 because that would be a 10. If this was an 8, that would be an 8. That's clearly not possible. You can't repeat a digit. So this must be the 9, and this must be the 7. Now we can take out the 9. Take out the 9 here. So 6 and 8. So this must be 6 or 8. So 7, 6, 2. That's 15. That would be a 3. Sorry, if this was 24 was total. So 7 plus 2 is 9, plus 8, 17. So that'd be a 7. So that's a 7 or a 9. Oh, well, it can't be a 7 because we've got 7 here. So that must be a 9. So that's 9, 2, and that's a 6. That gives us 8 here, and that gives us a 6 here. And so that corner is done. Okay, so we have a couple of interesting lon sums here. So 35 of 5 must be 98765. And 30 of 4 must be 9876. We need the 4 biggest numbers to make that total. And 4 must be 1 and 3. Now we have a total of 14 coming down here. Okay, so not seeing anything immediately there. Let's look at the 15 here. So let's see. So we have, if this is, so this is 8, then that would be 7. Okay, 7, 8. Well, obviously this can't be 5 because then we'd need a 10. So 6 and 9. Okay, well, let's say if this were a 7, if either of these two were a 7, then we'd need 1, 2, and 4 in the other squares because 7 of 3 can only be 1, 2, and 4. Well, neither of these have 1, 2, or 4 as an option, so therefore neither of those two can be 7. If this is 9, then we'd need 5. Well, that can't be 9 because the lowest option there is 5, so that can't be 9. If this was 8, these would add to 6, which is 1, 2, and 3. Well, again, that's too high, so this must be a 6. And we can take the 6 out here. This can't be a 5, or a 6, or a 7, because you can't make 17 with those totals otherwise, so this must be an 8. That gives us a 9 up here. We can take the 9 out there, and the 9 out there, and therefore this can't be 6, and this can't be 6, so this is 7, 8 pair in some order. This can't be a 6, and we know there must be a 6 somewhere, so therefore this is the only option for the 6 now. So we'll place the 6 there. This is therefore a 5, and this is the 7. This is an 8. That's a 7. Okay, so we've got 11 here. So this can't be a 3 because that would take us straight to 14, meaning that would be 0. So that must be the 1. That must be the 3. And then finish off the corner, 5. And that must be 2. Okay, now let's have a look over here. So 16 off 2, that's 7 and 9 in some order. 6 off 3, that's 1, 2, 3, 1, 2, 3, 1, 2, 3. Well, that can't be 3 because this would then be 3, 3, which would repeat the digits, so it can only be 1 or 2, which means that must be a 4 or a 5. Okay, so 20 off 3, so if this were 1, that wouldn't be possible, because we'd then need 19 off 2. If that's 2, it would be 18, which again would be 9, 9, so not allowed. So this is in fact a 3, and we can take a 3 out of the options there. Let's look then. If this was 3 plus 7, that's 10, so that would need to be 10, which of course is above 9, so that can't be a 7, so that must be a 9. That then gives us 20 minus, that gives us sorry, that must be a 9. That gives us a 8 here. Obviously 9 there, 7 here. So these two sum to 11. So if that was 4, that would have to be a 7. So that's not possible. That must be a 5. That must be a 1, 2, and a 6. Okay. Now let's have a look down here. So this is a 1, 3 pair. Well, if that's 3, that would be 3. So again, that's not allowed. So that must be a 1. That must be a 3. That would cause our 5, 1 ambiguity there. 6 we know is 1, 5, or 2 and 4. Okay, so that's can't be 1. So that's 2, 4, 5. 2, 4, 5. Can't be 2. Okay, a 10. Therefore, if that's not a 2, then this isn't a 4. This clearly can't be a 5, since that can't be 1. So therefore, the only option there is going to be 2, 4. That's going to give us an 8 there and a 5 there. So now we're just left with this center to resolve. So let's see, if this was 9 and 4, that's 13. Then these would, okay, these would have to add to 2. So in fact, this must be 3. And this must be 4. 5 is going to be 1, 4 or 2, 3. So let's look here. So now we have 9 and 3 is 12. So this is 1 and 2. Okay. 1, 2, and 2. This was 1. That would have to be a 4. That can't be the case because we have the 4 there. So in fact, this is a 2. This is a 1. This is a 3. This is a 5. Check puzzle. Okay. And that is how to solve a Kakuro puzzle using the handy technique where we reference across and down rows at the start to get a head start and give us some given digits in the grid. Thanks for watching. Hope you found this useful. Bye for now.